Right, this is page 44. We're using Z to calculate the mean. So these are questions finding the mean or the standard deviation. We start by finding the mean. So you could pause and read the question on page 44. If the probability that a student jumped less than 160 centimetres is 0.0062, calculate the mean length jumped. So along this axis we have all the lengths that the person has jumped, so we'll let x be the distance jumped, and that'll be in centimetres. So here are the distances along this axis. Now I know that the mean is down here, and that's what we're supposed to find. The standard deviation is given to us, it's 8 centimetres, and we're told that the probability a student jumps less than 160 is very small, which must tell us that most students jump more than 160. So that says that 160 must be down this end of the curve. And the probability that someone jumps less than that is the same as the area below 160 under the curve, and that area is 0.0062. So since we've been given the area, the probability, the answer, and we're working backwards, I can see this as an inverse problem. So if we hop over to our calculator, which isn't going to work. There we go. So we want distribution, normal, inverse. It's a left tail. The area is 0.0062. Enter. Standard deviation was 8. Enter. And now it asks for the mean, and now we have a problem because we don't actually know the mean. So at this stage we can't continue with the problem as it is because we don't know the mean, so we can't finish off using our calculator. So we just put that away for a minute. Now what this means is that what we need to do is use a bell-shaped curve, a normal distribution curve, where we do know, and that's a terrible picture, where we do know the mean and the standard deviation, and there's only one curve like that, and that's what we call the standard normal curve, and we give it the letter Z to represent the standard normal curve. And when you talk about a Z curve or the Z's normal distribution, we're talking about the normal distribution that has a mean of 0 and a standard deviation of 1. This is the most basic standard deviation, standard normal distribution curve we have. And what we do is if we draw it right below and we come down here, what we can do is, using that same area, work out what that number there is on the standard normal curve with a mean of 0 and a standard deviation of 1. So go back to our calculator. It's a left tail, same area, standard deviation is 1, the mean is 0, which is in there, and now if we go execute, it comes up with a value on the standard normal curve, so this number here, and the number was negative 2.5. The OO will round that to negative 2.5 fairly safely. Now, what your calculator is doing every time you use a different mean and a different standard deviation, it actually converts your calculations, and it converts your curve, in this case the curve with all the distances on it, to the standard normal curve, and it uses a formula to do that, and the formula is on your formula sheets. It's got a whole lot of things in it that you know. X stands for the number on the x-axis, on the x curve. There's our mu for the mean, sigma for the standard deviation, and it equals a value on the z curve. We call it z star, which denotes a value along the z-axis. So what's happened here is I've gone 160 on the x curve, minus the mean, which we don't know. Standard deviation originally was 8, and when I've worked that out, the value of 160 corresponds to a value of negative 2.5. And I hope you can see now that all we've got here is an equation that needs to be solved. For those of us that use Solver, you could jump into Solver. You'd need some brackets around here. and out will come a value for the mean. To make it a bit easier for ourselves, what we could do is multiply by 8 to cancel out that denominator. So we get 160 minus mu equals negative 20. I can see from this that mu is therefore 180, because 160 minus 180 would take me down to negative 20. You could also use solver at this stage. Use the x to stand for the mu, the unknown, in solver under equa, and out will come a value of 180. Just go back and look at your picture, your original curve of the distances jumped. Having a mean of approximately 180 sounds about right. So the mean length is 180 centimetres. Right, there's some more on the next page and we'll do exactly the same process. So you need to try 2 or 3 of these. So let's have a go at number 2. Weight of popcorn in the bags is normally distributed, so this time x is weight of some popcorn. Looks like it's in grams. Standard deviation is 1.5. If only 2% of bags contains more than 59 grams, calculate the mean weight put into each bag. So once again we're looking for the mean, and we're told that the probability of the weight being more than 59 is only 2% or 0.02, so quite a small amount, which tells me that 59 must be up the top end, and the probability of a bag weighing more than that is the same as the area under the curve, 0.02. Right, so once again I've got my answer, I've got the probability, so this sounds like an inverse problem. So we find our calculator. This time we want a right tail. The area is 0.02. Standard deviation is 1.5. And when I get to this stage, once again, I'm looking for a mean. I don't know the mean, can't put it in. So what we need to do is convert to a curve. Once again, it's not drawing. A curve where I do know the mean and the standard deviation. The z-curve with a mean of 0 and a standard deviation of 1. Make sure the two curves line up. And now we line up this value of 59 down here. The area is 0.02. And we'll work out this value on the z-curve. So now I have got a standard deviation of 1, mean of 0, and this number down here is 2.0537. We'll keep a few decimal places. Right, now the transformation that my calculator is using, every time I put in a mean and a standard deviation, it uses the formula x minus mu over sigma equals a z value on the z-curve, and then it looks up the areas on the z-curve. This formula is on the formula sheet, you don't have to remember it. Now the x value, the only value I have along the x-curve there is 59, minus the mean, which we don't know. Original standard deviation was 1.5, and when I did that transformation on the 59 I got the value of 2.0537 on the z-curve. Right, to make it easier for ourselves, we could times by 1.5 on that side. You can use solver anytime you like. I can also see that mu is the difference between the 59 and the 3. 59 minus something equals 3, so it's going to be about 56 point something. And working that out on a calculator, 55.9 grams is your mean. Right, there are some more questions there you can try.